What's up, goobers? Happy Sunday. It's time for more projects. Yeah. I think it's Mother's Day today. Let me check. Not sure if it's today or if it's next Sunday. Mother's Day is today. Yeah, I celebrated Mother's Day, with my family yesterday. So that's why I'm not sure if it's today. I got my mom I have no idea how to pronounce it. I think it's Bougainvillea, flowers. Okay, there's no S. Let me look up a pronunciation guide for it.
Bougainvillea.
Bougainvillea flowers. Yeah, I got the orange variety from the local nursery, so that was cool. My mom wanted specifically the orange and the yellow ones. Yellow ones were really hard to find. I didn't find them, but I did find the orange. And the person at the nursery, I told him that I wanted the orange or the yellow ones, and he pointed me towards where the orange ones were. But then I saw a bunch of red ones, and apparently the orange ones, how's it pronounced again?
Bougainvillea.
The orange bougainvillea flowers, they start off with like a very coral, staminy, kind of like almost red color, and then like they turn a really obvious orange. But the red ones, they start off with like a magenta, like a deep magenta. But the problem was that the red ones were under a bunch of shade, and the orange ones were not under shade, but I can't really say that they were under the sun either, because it was very cloudy when I was shopping for them on Friday. So, yeah. I grabbed the red ones first, and then the guy at the cash register, he was like, I think those are the red ones, not the orange ones. So, it's a good thing he stopped me from buying the wrong ones, because, like, yeah, my mom likes gardening, so, like, it wouldn't have been, like, a temporary thing that, like, dies after, like, a week. This would have been in her garden, like, forever. So, yeah, that's, is my video working quick enough? I'm not sure. Let me know if it's streaming correctly, because my preview shows it being choppy, but everything says that the stream is healthy, so I can't really tell right now. Let's see. So, Cradle of Pilth. Right now, I am just updating my Sea Lion installation, which has been really crusty and old. Yeah, and it takes like forever for it to update. So yeah, that's okay though, because we still have some things to do. We need to finish assembling the Cradle of Pilth, and then finish wiring up, or I guess start wiring up the Cradle of Pilth, and that alone is going to take probably an hour or so. And I also want to get the electronics housing, I want to get that set up for the Cradle of Pilth also, and so that's going to also take a while to print before we get to programming, so it's okay that my ID is taking a while to patch. But yeah, let's see. So I'm opening Fusion, and I'm looking up the what's it called? Looking up the files that I made, and let's switch over to the avatar view. Oh wait, I'm on ultra wide. Let me switch that to like 1920 by 10. No, 16 by 9. I think technically I'm like on 2560 by 1440, I think. But yeah, that'll fix the aspect ratio. I actually have some buttons set up on my Stream Deck for changing the aspect ratio, although I'm also kind of thinking of ditching the ultra wide and just getting another like 16:9 monitor, because honestly, I don't really get a lot of the benefits of ultra-wide that I thought I would. I only kind of get them in games. Even so, it's not really beneficial for, like, many, like, strategy games unless it's, like, a world map where, like, that is pretty wide. Yeah, I think it might be a detriment in League of Legends, actually, because, like, you see a lot of kind of useless, very wide area, and you don't really see as much on the top. But, yeah, and then I also have to worry about switching resolutions, so I might trade out this ultra-wide for just a 4K monitor. Not sure. What is the resolution of this ultra-wide anyway? Let's see. Display options. This ultra-wide is, well, it's currently at that, but it's normally at, 3440 by 1440. And what's the resolution of a 4K monitor? 4K monitor resolution. So yeah, I would actually gain vertical pixels if I got a 14K from the ultra wide. So yeah, that would not be a bad move. But it's not super duper important. I can just press the button to get it in widescreen mode for streaming, and then press it back when I want to get back to normal. But yeah, so we have the Cradle of Pilth, and the stuff that we designed last stream, the black top and bottom parts, and then the yellow sides, and then the red bottom shim part. I accidentally used the colors of the German flag for that. But yeah, that's I guess also is it Belgium that also has the same colors, but it's like sideways? Belgium flag. Yeah, it is. So yeah, that's what we designed last stream. Alexa, turn workbench light on. And so, ooh, that's close. Okay. Yeah, so I printed everything, and just because I got impatient. I mean, honestly, I'd rather test fit stuff. So I test fitted stuff, and there are a few changes. Actually, the only change I had to make really was this back lip was a lot shorter, and I reprinted it with that being a lot longer. When I realized that, like, the action to load this in, which this is what it's like when it's unloaded, I make it sound like it's a gun or something, and then you slide that in. The problem is that when it was lower, it would actually overshoot and start tilting, and then it just wouldn't go in neatly. So now that does stop it, and then we just take this, and it just magnets in place, and then you have this locked in. You can, like, shake it a lot, and, like, as long as it's not, like, super violent, because at some point this thing will get loose because it's just magnets. It keeps it together, and then we just load it into the roller, and it works great. So yeah, that's where we're at now. I also redesigned this part. Not redesigned, really, I just modified it a little. I got rid of that guide stuff because we're not using it, so there's no longer those two holes up here. And I also added these channels on the side here. Can't really see here, but you can see it a lot more here. Actually, it'd help if I turn the light on. There we go. You can see those channels here that help insert the screws, because the screw heads were actually being slightly blocked by that. So before, it forced like an order of operations thing where I had to put in the screws first, but I can screw this in, and then I had to screw this part in, and then I could actually assemble the rest of it. But yeah, tension on this is pretty good. So it only really needed some like minor revisions. But we're gonna have to disassemble this anyway, in order to install electronics, and later the, what's it called, wall mounting stuff, which I still haven't really thought about how that's gonna work. But yeah, here's a view of the magnets, And so it just pretend that the box is here. It just goes in here, and it snaps in. Yeah. So this is where we're at right now, and I'm pretty happy with all these parts. I don't think any of these are going to be reprinted or replaced. But we do need to do some disassembly anyway. Not total, but some partial disassembly in order to access where we want to install electronics. And I also just want to show how we are assembling this anyway. So, let's see, where's the T10? Yeah, T10 Torx. So yeah, this is literally all just countersunk plastic screws. I'll put them up in this corner. So yeah, as long as I don't assemble it and disassemble it too many times, the plastics will be fine, since they are made to be installed and uninstalled at least 5 cycles, and in practice, 50 cycles, I think, is until you actually start noticing stuff not really staying together. But yeah, here's the bottom part. Magnets. And then the 2 sides, I think, are technically identical, but I'm not 100% sure. We're gonna go take off this side, because we want to access the other side. Because the other sides are going to be mounting electronics, because the encoder board is there. But yeah, it is a lot easier to install now. And one more part is the bottom of these. I kind of recycled them because the sides need them and these still will need them. But I had some heat set inserts in here, and I just got rid of those. Now we just have some normal sized holes for the, well, not normal size, because that doesn't make sense. We have some holes now that just put the plastics in, because we don't need to keep going in and out of that. We just need to install it ideally once. And just assemble it for maintenance and iteration, which should not be common. But yeah, this is as far as I'll disassemble it, since it's pretty simple. And yeah, you get the point of it. So yeah. Alright. So let's assemble the rest of this. Let me go get my M3 screws. Hold on, I need to reorganize some cables, because my own head tracker is getting caught on stuff. Okay, there we go. Okay, head's not getting caught on stuff anymore. Okay. Gonna move this around a bit. Okay, so just need to find like no, that's not long enough. I'm gonna guess maybe 10 millimeters or so is what I need. And since the ends of these are like gonna be hidden anyway, I can overshoot a bit, and that's not gonna bother me as long as I don't look at it. Let's see, is that long enough? Yeah, that is. So we'll go with that. So I just need to find 2 more that are this long. I need to really reorganize these screws. I dropped them all, and I have not been motivated to sort them all out, but it's obviously adding a time tax to this. Oh, I have some black countersunk ones. If I can find those, that would fit the coloring better. Too short. And yeah, that is the length that I need. think I also may be getting low on a bunch of the sizes that I do need anyway, so... yeah, I also have, like, a big backlog of, like, screws that I need to sort, also. You know, I don't think I actually have enough of these in black. That are, like, both countersunk and long enough. Oh, here's one, I think. Yeah. Okay, just need to find one more. Nope. It's not countersunk. Are you long enough? Yeah. Okay, cool. And then I'll just got like 3 nuts. But we can't assemble them now because we actually need to wire up the screw or the switches first. Otherwise, it'll be blocked to access from here. So we got the micro switches. And the tiny screws. Yeah. Okay, so just gonna grab 3 of these. And then... I kind of just do it by... So, do you have a screw sorting tool, or do you just use calipers or something to sort them? I just kind of sort them visually, like, I just dump them, and then I, like, just take out all the nuts because those are obvious. I take out, and then I, like, split the countersunk and the socket head ones, and then I just kind of, like, line them up by, like, comparing them and then by eyeballing them, and it's generally pretty easy, until you're, like, down to, like, the 4 and 5 and 6 millimeter long ones. But yeah, I don't actually have any tools or measuring them. I just do them. I just group them relatively by which ones are longer or shorter, the same size, and then I sort them into their tackle box sections. But building a screw sorting tool using a robot arm and computer vision is something that I do want to do. And I think that's like the first project I want to do in ROS 2. So yeah, that'd be interesting. Okay, so how does this work? Or not how does it work, but how am I going to install it and stuff? Oh no, did I fuck something up? I think I did fuck something up on this print. Yeah, I did. Okay, so we're gonna have to reprint that part, but it doesn't take too long to print. But what happened is that there's this little tiny cutout here that is supposed to let the switch go down so that those holes line up. These holes? Yeah, those ones. But when I shrunk this down to 3, I think I forgot to put this feature back in. So, right now, those do not line up. And that's just too tight of a space for me to want to try to carve it out, so I'm just gonna reprint it. Feels a bit wasteful, but... I know, whenever I have to tweak it manually and then it doesn't look good, it just bothers me. So we're gonna... Oh shit. So I did it correctly on one of these, but I didn't do it on the rest of them. So yeah. It's actually just 1 millimeter. You know, I think I'm actually just gonna carve it out. Because it's good on this side. But if it ends up looking like really ugly, I'm just gonna redo it. Just redo the whole print. But yeah, it's only 1mm off, so that's not too bad. Let's change that out for a carving tip. Yeah. Okay. This is really tight quarters, though. And I think I'm gonna just switch between these two at a time, just so that, like, I don't overheat other stuff. And just make it look really ugly. Yeah, that's already looking kind of crappy. And the fit is just gonna get worse. And there's, like, almost no room to scoot around in here. Making it worse. Okay, I'm just gonna reprint it because I don't want to do that. Ugh, JJ, he stole my seat. Okay, yeah, we're just gonna reprint that. You're in the area that you're gonna get stepped on. Okay, but this should take like only 45 minutes, I think, to print. 1 hour, that's not bad. We'll do it. Okay, cool. So let's get it wired together, though. We don't need to have that installed to do that. Can definitely get started, at least, by kind of just estimating the wire length that we need. And a little bit of slack is never an issue. But the thing is that, let's see, normally open, normally closed. Every single one of these is gonna have to get its, like... Okay, so... these bottom ones, assuming that, like, the flappy part is opening up that way, the bottom 3 pins all need to be connected to either ground or 3.3 volt, and then the top ones, not top ones, the middle ones will all get their individual lines into a microcontroller, and yeah, so they'll get their own individual things in the microcontroller, and then they also need to be pulled down, which we can do in code, I think. And if we can't, then we'll just add some resistors, have it go to the opposite of whatever that common one is. Yeah. So, yeah, let's go do that. Okay, so, and I should also record the lengths of those wires too. Do I want to go with the finer ones? I think I want to go with the finer wires right now, and I don't know if the common is going to be ground or if it's going to be positive, so I'll just do it in white. But yeah, okay. So, where are my calipers? There they are. Okay. So the distance from each of these to each other is going to be about 50-ish millimeters. I'm going to add a little bit extra to that just to make my life easier. And then we're also going to have it go out one of these. I wonder what's the easiest way for me to do this. If I'm going to find like some really dumb, clever way to do it, that's actually going to make my life harder. And what I could also do, actually, just flip these upside down and use this as like a holding thing and just kind of solder from here instead of doing that from, what's it called? Instead of having like OmniFix to it and like get the distances and stuff. And it's okay, it's not like perfectly lining up right now because yeah. So how am I gonna do this? Because if I could like just yeah, this only needs like one break in the middle actually. So I'm gonna do something kind of funky that may or may not work, but will probably work. Okay. What I'm thinking is that if I can figure out how to just remove some insulation from the very middle, and this like super thin silicone insulation, so it shouldn't be too hard to do that. Either by making a break in it and then sliding it down, or just kind of removing the insulation. Actually, this needs a finer thingy. Yeah. Alexa, set lights to bright white. Okay, so yeah, this is doing what I wanted to do. That's good. Yeah, that's what I want to do. Just get that middle break exposed. And then just make sure that I have enough for the other bits here. Yeah. And then I can do some shenanigans, like twirl it around on the middle one, and then get the other ones on. Just verifying that that is the closed side. It is. So yeah, that'll be like that. And then the OmniFix so. Oh wow, that actually barely holds it like that. Okay, I'll take it. This is hot. And then, where's one of my fine tip ones? Fine enough. Got this up to 450. sponge. Okay. That should be good. Then let's solder this. Just doesn't need that much. Twisty these ends. Probably should have done that before. Because these wires are delicate, so doing it now kind of adds a little bit of stress, I think. Okay, so it's at that little hingy end. I'll just use the normal OmniFix equipment for this. Okay. It'd be nice to have like a soldering iron that size, but like completely self-contained and stuff, because that wire dragging places always gets me. Like with the power source self-contained inside of it, I need to twist this. Shaky. May have been because I just took my meds an hour ago. Okay. Oh yeah, that's a lot easier. Looks good. Just need to verify that it all still fits in here. It'll be hingy side down though. Wow, that is like stretched. On that side. And it's way too short on that side, I think. I think we're gonna have to redo this. Okay, we need to redo this in a bit longer than what we did this time. Ow. Okay. that is pulled off, and we'll just make it like probably a centimeter longer on each side. Maybe 2, just because there's also like the stuff for like the twisting and whatever. Okay. Got that. And then, yeah, this. Hopefully that is longer than the other one. Yeah, that's significantly longer. It's too long, we can actually trim it down. You know, that's what I should have done in the first place, is just overshoot it and then trim it down. Okay, let's try again. Would it be easier if I just insert that in now? And then... well, actually I think we just, like, kind of mock it up. That. And yeah, that'll be long enough. Just can't curl it all the way around, because there's just a little bit... it'd be just a little bit too tight if we went all the way around. So, yeah. I think it was like halfway-ish. Looked like it was a comfy. Okay. Just want to verify that that fits. If we were inserting it like this. That fits. And then last one. Yeah, we've got plenty. Okay. Sweet. So if we do the fit test, yeah, at least this thing is being useful. Oh, that's backwards. At least this this thing, which is not quite long enough, or not quite deep enough with those insertion slot things, is a good way to test these are appropriate like that, at least, which they are, so that's good. And then each of these is going to get its own signal wire coming out. And with that, I think that we'll just need to like kind of visualize if this thing is here, and if each of these things is like here. And this is why I wanted to get everything printed first with 4 wiring, just so that I could visualize stuff like this better. Yeah, this is probably easier to do upside down. So if this is here, then we can imagine the wire traces kind of go like this, and then this is going to be where the electronics box is. So let me just kind of like rough that out. That'll be like 100-ish by, let's overshoot. So the furthest one needs to be like 200, and then the next furthest needs to be like probably 150, and then 100, I think. And let's overshoot that to like, oh, JJ went on the futon this time. Yay! I don't have to worry about stepping on him for now. Let's see. Actually, I'm gonna do it in the iPad. Okay, so let me turn on air server. So let's do 100, 150, and 200 plus 25, which is going to be 125, 175, and 225. Don't think my calipers go that far, so I have to grab a ruler. Where did all my rulers go? I literally just have like a ton of them in there. Also, I need to go poop real quick. So let me go start an ad break right now. For Twitch, that is. Commercial 180. Okay, I'll see y'all in a bit. Okay, ducks, I'm back. Oh wait, let me wait for the timer to run out, because I don't know if it's been 3 minutes yet. So I'll just wait for that before continuing on, and let me go turn off your server. So we're back to the stuffs. Bless me. I should look for a ruler in the meantime. Found one. Alexa, stop. Okay, cool. So, the ad break should definitely be done. Let's go, get those wires then. So we're looking at, 225 first. And these don't need to be exact, because I'm overestimating, and we're gonna trim them down. And then 175. Oh, that's not a fine wire. How did that get there? These are fine wires. Okay, 175. And then 125. Okay. Sweet. Those are all there. And then... Okay, just want to make sure everything's the right way up. And which one do we consider the far one? So the far one is going to be this one, because we want to have everything kind of routing back here, I think. Yeah. And it'll be whichever one is normally open. Which I'm pretty sure is the middle one, but we can examine it again. And I'll just mark which one is the, I'll just mark which one is the outer one with, I guess the inner one will be marked with blue, since that goes to the blue wire. Okay, so blue one is going to be the outer one, or the inner one. And normally open, normally closed, so it's the middle one that we do want to solder it to. Is there a good way to fixture this? And access the middle. Oh, you know, could go sideways, yeah. Okay. More fine tweezers are bullshit. Okay. Got that one. And then green is the middle. tweezers. Okay. And then yellow. And then we also need to cut out 175 of white. Let me trim this, because that might actually short. Okay. And then needed that 175 white. And then yeah, looking at the 3D print, we're at 41 minutes left on it still. So we're gonna proceed with wiring up the what's it called? Encoder. Okay. Okay, that is soldered up. So, just to do a test fit again. This. And this. And this. That's backwards. All going into there. And then when these are all bundled up and fold at that point, they should be relatively-ish the same length. Yep, it's pretty close. So yeah, that'll help us determine where they go, and we're just going to temporarily hot glue it in place so that we can kind of estimate the wire lengths and the placement of the electronics. Let me go find my... there it is. Okay, so I don't think I've actually pulled this out for a stream yet, but I have some, like, wire here that is, kind of ready, like, it's already, like, 4 wires put together. I forgot what it's called. It's not, like, if it's not, like, a bajillion of them, which I would call a ribbon cable, this one's, like, only 4, so I don't think it's a ribbon cable. Seems a little grandiose. I mean, maybe it technically is, I'm not sure. But, yeah, so this part would go into here. And with that, let's just kind of estimate the wire lengths again. So we want this to go from here to that hole here, and then here. So if we estimate that path, I'm not sure if estimate is the right word here, it might be mock-up, I don't know. And let's add just a little bit of extra. I'll have that go down here. And then this is the only part that I actually want to use like a connector for, because it has to pass through here. So that's gonna be like kind of annoying. Thankfully, this is gonna be easier to do than the other one, because we don't have to like twist around silly pins. You can just actually put it inside pads and solder that in a lot easier. Where is it? 15's gone there. Where's a 15 here? So let me undo that. Okay. So, let's see. Oh, that's gonna be annoying. I thought I could do it all on that side, but I actually have to do like 4 of them on this side and 4 of them on that side. So, it's not as elegant as I was hoping it'd be. Still work with it. I mean, the way that the wires are, they aren't even in the right order to do that, so whatever. Okay. So let's strip these. And then I don't know if there's a color convention, color code for like SCL and SDA. Okay. Let me look up if there's a color code for that. Blue, SDA, okay, there's not really any color code. Rev does blue for S clock. Okay, I'm just gonna do blue is, scrolling the category and saw Cradle of Pilth, banger name for a project. Yeah, this project, is literally meant to hold, medications and track if I'm taking them at the correct time of the day. And, at the time I was listening to, well, I mean, to be honest, I don't really listen to, like, normal metal. I usually just listen to, like, metalcore and, like, screamo and post-hardcore and stuff. So I don't actually have Cradle of Filth in my playlist, but I've heard the name, and I figured that was a good pun, so I went with it. But yeah, thanks for tuning in. This is your first time. I make lots of projects with 3D printing and programming and microcontrollers and game dev and CAD and PCB design, and I just put them together, and it's just whatever the hell I want or need to make that does not exist, or I don't want to buy it. So in this case, it's a customized medicine tracker for both pill bottles and pill packaged stuff. Okay, that's kind of nasty, but that's okay because I meant to trim that off anyway. I'll just do it individually. Okay. So let's put that in. I think I'll need 2 of these here now. Well, actually, let's use the one that I made just for this. Okay, so I'm actually just gonna mark which one I intend to do. Okay, so first one is gonna be ground. So I'll do that in blue, and then the one opposite of that is power. So yeah. Can I make it go from here? Yeah, I can. Is there enough to at least tack that on there? Yeah. Okay. So ground is in, and then power. And then I might need to trim them flush, even though that's not like standard practice, just because of how I have this mounted. And then STL and SDA happen to be where they should be without having to twist any wires, so I'll take that. Okay. Let's put that in. Sweet. What's up, Fancy? Thanks for tuning in. Yeah, the YouTube and the Twitch chat both display on the stream. Okay, so this is not standard practice, and I think that a lot of things tell you that you probably shouldn't do this, but I do it anyway because this needs to be flat against where it goes, so I'm breaking that convention. But yeah, that will just go here, and so how the encoder works here is this chip here, it can detect when a magnet nearby is spinning, and this thing spins whenever the medications pass through it. And so in here, it's covered up, but it's glued in, but there is a tiny little magnet embedded into there. So if I put a little dot on there, you can see that it spins around there. And since the magnet's inside of that, and since this thing detects that magnet, that is able to tell when the magnet is spinning, or at least theoretically it should. Don't know that for sure yet because we're wiring it up for the first time, so it might not work the first time, but that's how it's supposed to work in theory. So let's secure this back on. Okay, cool. And then I sized this hole exactly so that we could fit in a GST XH 4-pin connector. In case we needed to redo this, I wouldn't have to resolder anything. And I never actually test fitted that, so let's go do that. Does this go in the hole? It does. Perfect. Okay, cool. And just gonna go crimp it in then. And I think I'm just going to do it in the order that the wires are in. And then let me actually switch to these guys. Okay. Then do the twisty, twisty, twisty. Okay. red one is not twisted enough. Yeah, this is my first time messing with the sensor, so this will be interesting. Normally I mess around with it beforehand, and let me just. I keep forgetting that hot glue gun is active, and it's putting hot glue on my. Oh my gosh! Did it actually? Oh no, it didn't. It just happened to be on the vent. Yeah, just got hot glue on the base of my drill. But yeah, this print is barely a failure, so I'm not securing it in properly. I'm just, because I can't actually do that, that's why it's a failure. So I'm just securing it with hot glue so that we can mock up stuff while the replacement for it prints, and just so that we can get an idea of the correct wire lengths for this. Okay, so crimp. Okay. So, the silly crimpy tool. Did that fuck up, or did that work? I think I fucked that one up. That's not the way it's supposed to look. Can I just pull this one off? Or do I have to retrim all of them to the same length? You can just pull that one off. Okay. Just gonna use the manual crimper. And I need to get another pin. Or another connector, that is. Oh! I found this shoe. These aren't even JST-PH, those are JST-XH. I thought I sorted them out, but I guess I did not, but that's why it did not work. Okay, so where are my XHs then? I should have a lot. Okay, this one's out. Is this one still good or is this one bent? That one looks like it's still good. Just a little bent. I can unbend that. Okay. Then, trying to find one more. Here. Okay. Let's go with that. The background sound effects might be from a game. I actually made the background music for this. And a lot of those sound samples are just, like, pretty common, like, not free use, because they're from, like, a paid license pack, but, like, the kind of stuff that, like, both movie editors and game devs would use to get sounds from. So, yeah, some of them might be. I was going for, like, kind of like an ambient cyberpunk city vibe thing with, like... I actually don't know if you're listening to the pure background music or if you're listening to the one that has sound effects. I'm guessing the latter because you're talking about the sound effects. But yeah, that's why you hear, like, police sirens and, like, helicopter things and gunshots and stuff. Don't worry, those are not in real life. Okay, I don't think that actually crimped properly. those are not IRL. Yeah, if they were IRL, I think that I'd have some really weird, exciting things to stream. It may not be YouTube or Twitch friendly. It might have to go on Kick. Okay, is this one? Yeah, that is the correct crimp. I hate crimping. This is like one of the things that I hate doing the most, but the advantages are worth it. Okay. Hopefully that is good. None of them feel like that they'll pull out. Okay. And doesn't matter if it's backwards or forwards because I get to control the pin out. Okay. So that's in. Oh. I need to pull that out just a little bit. Might have to get my super duper tiny flathead for that. Okay. There we go. That's lifted out. Now we can install that one. Yeah, it's the little tiny I'm not sure if the GoPro will be able to show you. But there's like these little kind of like hook things at the end, and one of them was pushed in, so it wouldn't be able to stay in unless I took that hook thing and kind of stuck it out. And that's what keeps it in place. Okay, there. And then just to confirm, we can put that right in the hole. So if we ever have to replace a part or disassemble this or whatever, it's not a big deal to just unplug this and put it in. But I'm not going to do this for every connector because that just introduces more chances for unreliability. Okay. So this can go in either this way or this way. I think I was going to have it go underneath. Don't think I want to permanently install that yet, though. Okay, we're at 19 minutes until... We should probably check if the print's actually working. Yeah, print's looking good. So, what next? Let's go back to the schematic I drew up. So... we have the AS5600 encoder, which we just wired up. We have the micro switch things, which I don't think we need those pull-down resistors because... Oh, I think I remember that we actually want to pull them up because pull-down is more reliable to detect. Or not pull-down. Ground is more reliable to detect than reference voltage. So yeah, let's, I think that means that should be pulled up instead of pulled down. So, yeah, let's fix that. Red. So yeah, that's actually gonna be pull up. But is that the symbol for it? I don't think it is. I think it's actually just that. Okay, anyway. So yeah, I want to have an LED on there. Actually, we'll just make that a NeoPixel, because, I have a bajillion of those, and they are really good for debugging things. so where are my light strips? Or can I just grab a single neopixel? I'll reuse this one. Yeah, this guy. Okay, so let's do 2 of them, actually. Actually, do we ever need to do that? Can we just reuse this? Let's just reuse this. Not just lying around. Okay, so this is actually gonna be neopixels, and let me just redraw that, I guess. Brown. So, light strip. Okay. And then display. You know, I don't think we need a display. Let's just do the light strip for now. That should be good enough for some debugging, as well as a serial line, since this thing is going to be talking over serial anyway. Okay, so we have the encoder, we have the, 3 micro switches, we have the light strip, and we just need the buzzer. So, I'm gonna go get the buzzer out, but I think this is the time to, actually put this on, like, on a perf board. So where are my electronics MISC, I think? Is the box that has my buzzers, I think? Yeah. Here's a buzzer. I do remember there being an issue, though, with the buzzer's last project, where I think it was, like, drawing too much power or something, so we might have to add, like, a resistor in there or something. But, yeah, I think I should probably just get out my box resistors also. Because we're almost certainly going to need at least one of those. So yeah, I'll just be hanging out there. Perf boards. Okay, cool, I did pack them all in there. So yeah, we have a bunch of sizes, and I'm just going to be using the really small C Jow form factor. So I'm going to find one of those microcontrollers out of my bin of microcontrollers. Maybe here? What are you? You are not the microcontroller I thought you were. Okay, what are you? ESP32C3, let's go with you. Brand new, fresh, unopened. And that also means that we're gonna need the headers and terminals. Okay, this is actually a lot of shit right now. Let me, reorganize a bit, because I'm starting to get lost in all these parts. Okay, so I don't need the drill right now. I will need this, but not at the immediate moment. The wire stripper's away. Don't need the crimpers right now. Yeah, that goes there. Probably won't need those tweezers for a while. Roller there, that thingy there. Keep this out of the way, because it's hot. Don't need the carving tip right now. Okay, back there. Put y'all back here, yes. Okay, yeah, that should be fine. Okay. So, I'm gonna actually put those components here since we're actually gonna be using them soon. So where did I put that microcontroller that I literally just got? Let me put you here. Here it is. Oh yeah. Ended up here because I was looking for awesome driving training setup. Yeah, I haven't done a video on that yet. I've only posted like video clips of it on the NHRL server. But I do want to do more stuff with that. Where did I put the microcontroller? Did I unbox the microcontroller yet? Or did I already lose the microcontroller? Okay, I did not throw it away by accident. That's what I was worried about. But where did I put that microcontroller? I forgot. Did I already take out the microcontroller and show y'all? What are you wiring? Curious what the current project is. So this is the CRADLE of PILLTH. It holds my medications, and talks to my AI assistant so that it can track if I have taken my meds for the day or not. Oh my gosh, I think I just lost that microcontroller. Is it in my pockets? Oh. I realized that my water thingy does not have a cup in it, so let me go get a glass. Real quick. Okay, so the glass of water is in the thingy that should be in. But what is not where it should be is that microcontroller that I just unpacked and apparently lost. Put it off to the side where I said I was gonna put like the little thingies that I'd be working on. Okay, it'll come up somewhere. I'll just grab another one. I have like a bajillion of these things. Okay, back to the bin of microcontrollers. I say that, and that's like gonna be my last one that I have. What is this one? S3. That's overkill, but at least these things are interchangeable, so... relatively interchangeable, that is. Lithium battery charger, a way bigger ESP32 that I need. Here's a different brand of one. Here's a S3 or C3. I can't read that right now because it's too small. Need some light for that. SD card reader, SD card reader, SD card reader, Raspberry Pi, big ESP32. Don't want to use one of my big ones. Okay, what are you? You look like that. You're also... Here's a C3. DF Robot branded one. I'm not sure which ones are just hanging out here because they're actually dead. No, that's a Raspberry Pi Pico. And you know what, that may have actually been the last sealed ESP32 S3 that I had. But that's okay. I'll find it later. And I have a bunch of, I found a few already open ones. I don't know if I just used them like one time and then kind of forgot that they existed, or if they're like burned out and kept them for some stupid reason. Whew. Okay. So, yeah. Here are microcontrollers. This is a ESP32C3. This one is an ESP32C3. Hopefully we can use this one because it's shape and the power that I want. And I have an S3 here, which is way overkill for what we, like, even the C3s are really overkill. But I don't think they make the normal ESP32s from here. Closest event to me is 12 hours away by car, and there's no robot combat scene. I want to change that. I'm building an 8 foot by 8 foot cage, and a training tool like that would be awesome to integrate. Yeah, the point of the training tool is so I don't have to go all the way for events to do that. And I am a bit spoiled in Texas because we do have some really good events in Dallas, but I live in Austin, Texas, which is like still a 3-hour drive, so it's not trivial to compete. And also Norwalk, Connecticut is like a 3 or 4 hour flight for me also. So yeah, it gets pretty pricey to keep fighting around the country. So I wanted a training tool to get a lot more experience without having to go to all the events to grind for that, because that's just really expensive with all the parts getting destroyed and all the travel and just all that stuff. Okay, so let's see. Is Sea Lion ready? Because if Sea Lion's ready... I don't think Sea Lion's ready yet. Sea Lion is the IDE that I use. The 3D print's almost done, though. But we do have 2 ESP32 S or C3s, plus one that is lost but exists still. So we can at least get together a board and solder it up into stuff. So let's do that. And trying to figure out what size board we need. There's like 1 or 2 giant boards in here. I don't want to waste that on something that is really small and will have barely anything on it. So I'm thinking probably one of these. I'll probably just go with the larger of the 2, just because in case I wanted to expand functionality past what I think it needs right now. So let me go pack those back up, because this thing has like a specific sorting order to it, so that it can fit in the box again. Okay. And so Sea Line's still installing, so we won't be able to validate if that if the controller works. But we have a lot of controllers, so we can definitely just keep trying until one of them works. Found another sealed ESP32 S3. Okay, so yeah, it's not that big of a deal. So let's see. This needs to go here. I'm gonna use some headers so that we can replace it if we need to. Especially because it's really easy to burn stuff out when you don't want to, but it still happens. So let's size those up. Okay, there's a file or some sandpaper. Here's one. If you're ever in a pinch, nail files are pretty good sandpaper replacements, because it is literally sandpaper. I think this one actually has the same grit numbers that you'd find for like sandpaper at like a hardware store. and it's like kind of ready. Like if it just needs to be like pre-solid in whatever its shape, or I guess rigidity, it's pretty good. And you can just find them at like dollar stores and grocery stores and pharmacies and stuff. So you, like, if Home Depot or Lowe's or whatever is closed, but you need sandpaper, don't need a specific kind, then that can work in a pinch. Plus, it's just kind of a convenient form factor anyway. Okay, that should be good enough. Let's see. So, I'm thinking that we just put this, like, here-ish. Don't really have to worry about optimizing for size that much. And it'll probably be mounted like this. Okay. Let's take that. And should have one of my, oh, already put them back in there. Okay, this one's gonna be a little bit awkward to mount. Okay, cool, that'll work. Putting some flux on here. And then I'll pin the top two. And then just wedge this in until it's just right. Okay, cool. Don't need to do that awkward leveraging now. Can do the rest. Okay, the 3D print is done. And I think just so that we can get the next print started ASAP, we'll just assume that this is going to be where that lives, and just build an electronics box around that, which should be super simple because we already have these holes in here to mount on. And just to make life easier, I'll probably just have it in the middle of it here. And then we have the holes in here ready for more mounting stuff. C-Line is still upgrading to... It finished upgrading from 2024 to the end of 2024, now it's upgrading to 2025. It's been upgrading for like 2 hours now. I don't actually know if we'll get to the programming part tonight, or today. But, okay, so let's go back to the base thingy. And box right, box left, and this is where I wanted to put the electronics box mounting. No, actually we could get away with that pretty easily. Let's do that. Okay, so we're gonna get the center of this. And then 6 and 6 should be good, I think. Actually, let's just use heat set inserts. That'll be pretty easy. Yeah, that is an Omnifixo, actually. Yeah, it's have the normal Omnifixo things, and then these things here I actually designed a few streams ago, and I am testing them out, and I have a couple friends testing them out. But if the design turns out pretty solid for everyone, I'll go post the files publicly. I don't like posting my files early, though, just because I don't want people to have the expectation that it's perfect and then they hate it and there's actually bugs with it. I rather test it out first before posting it. But yeah, those will be public very soon if everything works out well. I forgot to do those holes. Oops. Okay. I guess I didn't actually have to put those holes in anyway. And then, just so they don't merge, because even if I do new body, sometimes they still merge and I don't want them to. And what heat set inserts do I have that are M3? What are the flattest ones I have? It's probably gonna be these guys. Calipers are here. So yeah, that's 4. And that is 5. So let's go 5 thick, 5 millimeters thick. And then here, let's widen that to 5 millimeters and make that go 4 millimeters deep. -4. And then pattern for this. So the raw size is, we'll round it up, 51 by 71. Okay. And that's just for me to get an idea of where the board sits. And then the actual hole pattern for it. Those are M2s, and this thing's not going to see any loads, so I'm just going to directly thread it in with my M2 screws. So that's going to be 2, and let's get the holes for that. 66 millimeters by, I'm going to guess, 46? Yeah, 66 by 46. 66 by 46. Perfect. And this will be the bare bones mount for, wait, I forgot to construction line that. There. It looks real cool, although I already have access to decent soldering gear. It's all automotive stuff and not particularly well suited for precision. Would you recommend the M4.4? I forgot if that's the name of it. M4.4 OmniFixo? Yeah, okay, so that's what it is called. Yeah, I completely recommend it. It's the best helping hand system I've ever used, and the only reason I made those extensions was because, like, you can use 3 clips to hold, like, one thing very stably, but then that only leaves 1 clip left for whatever you need it to do. So, just by having those extra ones, it just kind of helps, or the ones that I made, you can secure an entire board down with just a single clip. If you're doing robot combat stuff, you can hold an entire ESC in it, in just a single double wide clip, and Yeah, it's pretty convenient. Okay, so this is gonna hold the, actually I want to offset this a little bit. Just because the solder connections will not be flat. 6 maybe? Yeah, 6 will work. So that'll be offset by like 2 millimeters. Well, let's go 3 just to be safe. And then we don't need all of that to be as big as it is, so we can do some lazy pocketing, yes. Let's go with, say, 4. Or actually, let's have it so it's all covered up by the PCB. 9. Oh, wait. Actually, we can just do, like, here, 49 by 69. Oh, that's already 69. Nice. Okay. So, -4. And then just, gonna round that out. Okay, so let's 3D print that. And we don't need to make a shell for it yet, because all that'll do is just help with like waterproofing or whatever. We just want a solid point to mount the whole PCB at anyway, so that we know the wire lengths that we need. So yeah, we don't need to go design and print that part yet. It's kind of a mundane part, so I don't really want to design it right now. Although we are getting to a good point where, and not a stopping point, I'm going to be going for like at least another hour, but we are getting to a point where I think next stream might be the last stream for Cradle of Pilth, and we can start a new project. Okay, 30 minutes, that's good. So yeah, this will adapt the PCB to the Cradle of Pilth. You know, I'm gonna be lazy. Let's turn off bed leveling. It's pretty good right now. I mentioned it before, but like the other helping hand systems that I've used, the kind that have like the ball joints that you tighten with the screw tend to get like really loose really fast. And the threads on those screws are just not meant to hold things, and like they also kind of get loose and tight in really uneven ways where like you move it like 5 degrees in some way and it gets super loose, and then you move it like 5 degrees another way and it gets like really tight, or like too tight. They have to keep undoing and redoing it, and I just don't like that. And then you have like the gooseneck stuff, and those will just kind of wear out over time and they don't really keep their place. And the ball joints on the OmniFixo are magnetic and very smooth, so you don't get that issue. And a lot of the helping hands things, they have like alligator clips, which are really bad at like leaving marks on whatever you're doing. If you're putting like wire that has PVC insulation, then it just bites through the insulation. It can also just slice through the silicone insulation. It's just not good for insulation at all. The OmniFixo uses like these parallel jaws, so it doesn't bite into it because they're completely flat, and it can also hold like any thickness of object without it being like arbitrarily like too acute or too obtuse of an angle to really grip on. It's always like parallel, so that's pretty nice. Let's see. How are you doing on C-line installation? We're still taking a while. Okay, let's just get the pinout of ESP32C3. And I think all of the C-Jow things have the exact same pinout for like really common things like SDA, SCL are always going to be on D4, D5, TX, RX are always going to be on D6, D7. The 3 power rails are always going to be there. So if we need to switch between the C3 and the S3 or some other random one, it won't be a problem. I would like to use the C3s because they're not overkill, and I want to save the S3s for things that actually need some heavier lifting. But it won't be a blocker if we have to use the S3. But yeah, I guess now that we have that pinout, let me go turn on the diagram on the Mac again. And just referring to that pinout, let's actually figure out what those go out to. So, that's going to be D4 and D5. And then these, I think I'll just keep it simple. Let's have that be D0, D1, D2. And then let's have D10 and D9 for the buzzer and the light strip. Yeah. And then I think those are all gonna need some like power rails, so I'll go do that. Yeah. Okay. So red. I'll just grab all my colors of these. Okay, so I think power rails are just gonna be along there and along there. No, actually, I'll just have them on the back. Yeah, let's do that. So the way I like to do power rails is a little weird. Kind of just like to have like one long ass thing like that. Sweep through that. And then kind of do it on like a parallel rail, I guess. Do I want to do it like that? Yeah, sure. And then it becomes pretty obvious where to solder it. And just so that they don't accidentally cross, I'll actually skip a row. And it's okay, that's not like perfectly aligned. It's aligned enough. Oh my gosh, this is getting caught with the soldering iron. Or not soldering iron, the hot glue gun. I'm just gonna unplug the hot glue gun. Don't think we're gonna need it for a while. Just so that the wires can see out of the way. Okay. Did I ever take that thing off of... I did. Okay, cool. Okay, those power rails are in. We can trim those ends. And then we can dupe these ones in. So ground goes across there. It's the second one. Yeah, it's the second one. And we'll just have the very end be ground. Okay. Okay, and then solder that. Calipers are getting caught on that. Trim that. And we have ground. Okay, let's get power rail. Let's do 5 volts instead of 3 volts. What's up, Nabel? Hi. Thanks for tuning in. Let's see, 5 volts. Okay, so let's have you go here. Fold that down, and then we'll have it be about here-ish that we have to bend it there. Okay. So that goes there. That goes in there. And then we bend that, and we bend that. Clip that in, and then solder. I think that actually, there we go, that's better. Tip's getting kind of nasty. Need a new sponge for this thing. Okay, and then just flatten that down a bit, and then give it a little bend and clip. And then solder that on. Sweet. And our 2 power rails are there now. Yeah, I hope that the OmniFixo works in with 8S and an 8x8, what's it called, arena. It sounds like you're going for the 3-pound class, so yeah, that should be able to handle, like, everything that you need for 3 pound. Let's think the only component it can't really hold is probably just a battery. But it'll at least hold the clips or the ends for a battery connector if you ever need to redo that. I think the clips are actually even big enough to hold some ant weight motors. Okay, so I think it's time, actually, to install the micro switches into the real ones, into the finalized holder things. Just need to take off that hot glue. And so I have these diagonally so that I don't have to like worry about like putting those in at a weird angle. Where are my M2 screws at? That's resistors, headers and terminals. Did I put them away already? I don't think I did. Too many parts. Ah, here. Okay, so I don't think I actually have that many in the length there. Oh, I can use these ones probably. These long enough? Ah, they're just barely too short. Okay, we're gonna have to use these ones down here. Okay. At least we only need 2 per. But yeah, these are not high loads, so just directly screwing it in. I'm actually gonna go put first one into all these first, just so that we don't have to worry about accidentally pulling stuff. And then having to redo the soldering job. Especially since these ones were a little bit of a pain in the ass. Not the worst, but still annoying. And then this last guy here. There. Okay, cool. So yeah, that all sits in there pretty nicely. And then let's put the bottom 3 screws in there. Yeah, I think the fact that they're Swedish, and that you're importing from Europe, well, I just assumed that you're in the US, but, yeah, at least stateside, the OmniFixo is not the cheapest option, but it is worth the premium, I think. Actually, if the nearest event is 12 hours by drive, it's likely that you're not in the US, unless you're, like, in like, the prairie-ish area. Since there are plenty of robot combat events in most of the country. I think even Hawaii has some. Alaska might be a place that is really devoid of events, I think, that are nearby. I've never heard of an Alaskan robot combat league. But they exist in, like, Utah and Idaho, so yeah. Okay, this one's not going in. I wonder why. It's just not pushed in all the way enough. Yeah. And then just to show the, where's the pill bottle I've censored? Okay. So yeah, this, it turns out there's several there's like a few standard sizes of, pill bottles. Let me go censor this one real quick. Okay. So yeah, this is from Amazon Pharmacy. Where did I just put the other one? Ah, yeah. This one is from HEB. That's a grocery store in Texas. And, had one more example bottle. I can't find it. I may have put it back already because it's not mine, it was my partner's. But, yeah, so there are standard sizes of pill bottles. Like, these are 2 different pharmacies, and the bottle sizes are the exact same. So, based off the most common pill bottle size I had, which is this one, this perfectly seats into here. And you can hear a clicking sound. Actually, my microphone's here. That clicking sound. So, when a medication is in here, then it trips the switch. When it's taken out, it undoes the switch, and this is how the device will know that a pill bottle is in there. And we're assuming that because the pill bottle was taken in, or taken out, or it was put in or taken out, that the medicine has been taken, and it can also scream at me. Oh wow, yeah. Sweden. Okay, oh, so you are in Sweden. Cool. Yeah, the closest events I can think of, let's see, I generally know where it is, but I don't know how close you are between the US, not the US, the UK and, I type in Swedish, between the UK and Estonia, but I believe those 2, oh wow, you're actually, I don't know, because if you're in Stockholm, then Estonia is way closer. I mean, Estonia is closer than UK, but I think your closest events will probably be in Estonia. But I don't know if they're open to the public, because the last events I heard of that were in Estonia, I think were student only, and I don't know if you're a student. But yeah. The Estonian events are getting really cool, because I think that they're supporting, some pretty larger weight classes, like not heavyweights yet. I mean, heavyweights are so expensive to do. But, I think that they're doing up to whatever the EU equivalent of, 30-pound classes. I think that's... I don't know if y'all do, like, 15 or 20 grams or something like that, or if you just use the British featherweight class. But yeah. Doop, doop, doop. These are all the same lengths, I think. That was the intent anyway. Yeah, they are pretty close to the same length. Okay, so yeah, that goes into here. And, I think that now that this is assembled, we can actually get the, get that stuff fired up. And just to make that easier, I don't think I'm gonna sleeve it. Nah, fuck it, I'm gonna sleeve the cables. Where's my purple sleeve? Got my pink and my... Here's some purple cable sleeving. Where's the end of it, though? Or do I have to... like, untangle all of this to use it? If I have to untangle it, I don't think I'm going to use it, but if I can find the end of it, I'll do that. Here's the end. Okay, so I'm just gonna estimate 10 centimeters here. Oof. That got janky. I have heard of Fairbanks, Alaska, but I'll be honest, I don't have Alaska's layout memorized. I just know that their biggest city is, like, nearest the southish end, like, on that really skinny strip near Vancouver. Okay. That's kind of ugly, but that's what heat shrink wrap is for. You know, that's actually longer than it should be. Let's cut off some of that very frayed end anyway. Should just use my titanium scissors. Okay. That should be melted enough. Clear heat shrink. Is this gonna be skinny enough? Let's test that out. Oh, okay. Yeah, that'll be skinny enough. We can use that. Okay, so let's thread all of this through there. What's the easiest way to do this? Probably something like that. Just inchworming it across. I was just gonna use like a, what's it called, zip tie. It's like, you know, let's make it a little prettier than that. This part may have gotten a little too crunchy. Tweezers. Okay, we're really close. We just need to pull that blue wire up. Blue wire is up. Thank you, friction. And then just make sure these are all kind of like evenly tight. Green, I think, there. And then pull blue a little bit more. There, cool. And then, yeah. And just heat shrink that. And then, yeah, I'll just tilt it up with that. Do need to be careful because this is a PLA print, so too much heat will deform the print around it. So that's why I'm not going to go too hard on cleaning that up. I might just glue that in place also just to keep it nice and secure. Okay. That part is now nice and bundled up. Okay, so y'all do use the more British and American weight classes then. Interesting. At least I already got the university hooked on it. If I can make a cage before September, they will spend the 2-month mechatronics course building the combat robot. Yeah, I'd say that's a pretty good amount of time, to build a robot, especially in a group. Yeah, that sounds like a pretty good timeline, and it is May, and September is a thing. That's like 4 months away. So, yeah, that sounds like a very reasonable timeline to me. Yeah, definitely make sure that you're using, if you're doing 3-pound, definitely make sure you're doing like a 1/4 inch, I think that's 6 millimeters, double polycarbonate, or 3/8 inch single layer. I want to say that's like 8.5 millimeters of polycarbonate, and then you should be good. At least for the next 5-ish years, because power creep is why the standards keep going up. Because brushless motors and LiPo batteries keep getting better and better, and if you're really cramming 8S in there, then that's definitely pushing the bounds of it. Okay, so I was wiring this in, and I'm just gonna directly wire it, I think. Let's see, I was doing D0, D1, and D2. So, what was that? D0, D1, D2, there's at the top right 3. That'll work. Yeah, there's plenty of room. I think that they're all gonna be the same length, too. Something just doo-dooped. What disconnected? Yeah, okay, y'all can still hear me. I see the mic going up, and my trackers are still going. I'm gonna assume that it's not anything important that disconnected just now. Twisty, twisty, twisty. It sounds like the print is done, because I hear the bamboo respooling, and it's not out of filament, which is another time that it tends to make that same noise. Okay, so let's tin this. Oh, that's right. I actually did get some soldering paste, which I actually prefer for tinning. Let me just do this one normally, and then I'll show my trick that I like to do for it. But yeah, so I like to go kind of like rainbow color order, so that's why it goes yellow, green, blue. So if I have like Roy G. Biv, for example, colors, then I'll use that for going like sequentially in some way. I'm actually not going to trim that yet. Let's just do one at a time. Okay. So, this one into here. And that is D0. Green is next. Why are my fingers so shaky today? It's really weird. They're not normally this shaky, but it's not ideal for soldering. that is in. I think I'm gonna just tack this on first, and then bend it around. Yeah. That's a little close. There we go. That's better. And then let's trim the excess on both of these. And then blue. And if we need to add pull-down resistors, we can do that pretty easily. But I don't think we need to, because I'm pretty sure the ESP32 actually has them built in. No, sorry, pull-up resistors. Okay, cool. So that is in, and this, I'll just kind of have it off to the side here-ish, and then we'll connect it to one of the power rails, I think. Oh yeah, so the different way of, where did I put it? Is it up here? Yeah. So, this is, solder paste that you'd use for, like, what's it called, surface mount stuff. But what I like to do for some, like, ultra thin and, like, nice, well, evenly distributed tinning is I like to use this stuff. Oop. I think I actually should have put this on first while this is closed, and then it should click into place or something. Why is it not doing that? Hello? Does it screw into place? It's not doing that. Whatever. Now it's probably like weirdly pressurizing and gonna like splooge everywhere, I bet. Get it fast enough, it should be fine. But why is that not clicking in? It normally does. Well, anyway. Just putting a little bit of this stuff on here. Ooh, that's a lot. But that's just because it was like the first goop of it. And then just hit it with the hot air. And it distributes like super duper thin and evenly. And I like to do that for that. Yeah, 10 millimeters is definitely gonna be way more than enough. But more than enough is a lot better than less than enough, so if you have the money to swing it, I would go for it. I guess setting it up will also be harder if it's heavier, but hey, safety's important. Okay, so let's see. If that was pull up, that means that ground should be the common thingy here. So let's do that. There we go. It just kind of bent in a weird way that I didn't like. And it's probably a good time to check on the 3D print after I get this part soldered. so that's the 5th column. There we go. Okay, so that is crunched in there. Fill that over. Itch. And that looks solid to me. Okay. So we have this, and let's check out that adapter plate that we just printed. So that if it doesn't work, we can just make revisions and keep going. Okay, so where's my M3s? That's M2. There's M3, but I took the baggie out somewhere. There it is. There it is. And I frankly don't really mind if I use a normal soldering tip to push these in, even though it does cause a bit of wear on it. Well, actually, no, let's do it the proper way and just change out this decent tip for kind of beat up one. Yeah, this one. Let's get it down to, let's do 280. Oh wow, that's really heavy. That's like 1/4 of a ton. Yeah, hopefully that's not too heavy for y'all to set up. But also, just because like a cage takes up so much space, and that can really be a deal breaker for like keeping it permanently installed, what you could do is like do the driving, like if you want to do a similar like driving projector thing. Ooh, that one twisted. Ooh, water. Whee! Water. Woohoo! Thanks for redeeming the hydrate. Okay. So, those went in great. And we can mount it up here or down here, depending on what's better for the wiring. Just need to make sure that this fits onto here. And if it does, we are in business. Oh shit, I just realized I forgot to, well no, we can actually hijack some of this. Or we can just remake it. It's not that much plastic. What I just realized is that I didn't add any way to, put the top on. Okay, this is not gonna need that much, so we can just get with these super duper short screws. And I didn't actually realize I had M2 heat set inserts. If I did, I would have designed around that. So if we need to reprint it, I'll add those heat set inserts also. But it is kind of small, so I'm not sure if I trust it that much, but that's what rapid prototyping's for. Okay, that is the right size, at least. That's good. I'm not going to do all the screw holes, because we're going to undo it anyway. Let's just test fit. Okay, that is looking good. And then, if we just put this onto here, get the holes to line up. There is one. There's another. The holes do line up. And let's just grab a couple random. It doesn't matter if they're actually the right size that they should be. Actually, those happen to be the right size. Nice. going in kind of blind here. That looks like it is going in, though. Yeah. And then the others are easy to line, and as long as you don't go too tight on this, it's not going to split. Because that is one risk of when you, like, 3D print something and have countersinking that's, like, not normal to the layer planes, then the countersinks can split them if you go too hard. So that's something that you have to be worried about. Worried might not be the right word. This is something you just need to take into account. But yeah, so if this thing sits like this, then this is actually just the right length for that. So that's exactly what I wanted. I didn't want too much extra slack on that. Oh wow, that got twisted. That could have caused some extra strain. But yeah, let's take this off for now. Because we're still working on it. What soldering iron is that? I haven't seen hot swappable tips before. This is the Pine-Sol soldering iron. I think it's a V2. Yeah, this is the V2 Pine-Sol. And there's actually a whole family of soldering irons that do this. So Pine-Sol V2. It ships from, I think, either Australia or the EU. It's not from the US. But the V2 has this, like, green cover thing. Oh, actually, this is a perfect, comparison. That's doing the redirect notice stuff. I'll just do this. Okay, so yeah. This, all of these except for, I've never seen this hand skit one, or the bacon one, but like, at least, let's actually just open up Paint. Okay. So yeah, out of these ones, I know for sure that the easily swappable ones are going to be the Pine-Sol and the TS100 and the Pine-Sol V2, and there's a few others that follow the same standard, but these all take in the same one. The V2, you'll see that this has a shorter tip, but it's still compatible with the longer tips and vice versa. The TS80 has a different standard that looks like a headphone jack, but I believe the TS80 was actually the first one of these, like, very tiny form factor ones, and something really nice about it is that for most of these, you can actually power it up with either just a normal barrel jack or USB-C, and if you have a strong enough power bank, which I think is like at least 60 watts, you can power it off of a power bank, which is really nice for robot combat events and stuff. But yeah, it works great for everything kind of smallish. I don't recommend it for like really big, thick wires. Like, I try to use it at BattleBots on Bloodsport for the motor controllers, and it was just not strong enough. But I don't work on the heavies here because Bloodsport lives in Boston and I live in Austin, which is half the United States away. So, yeah, that's, this is good enough for at least 3 and probably 12 and even 30 pound, I think. Where is the thingy? We have the, okay, so we test out the PCB mounting adapter plate, and that works, and this thing works. At least in theory it works. It physically works. It fits together, that is. We have that wired up. We need to get the encoder in there, and then we have the bare minimum of what we need to actually test stuff out. C-Line is still installing. It's finally upgrading to C-Line 2026. This is a long-ass update process. I should have done this overnight, but oh well, there's still stuff to do. So yeah, you can kind of just see how long this needs to be. And honestly, it could go anywhere on here, and I think I'm going to have it just go on the bottom here somewhere, just so that we can reserve the top row for things that are near the top, because, yeah, that's me using D4 and D5, and that's the I squared C stuff. And that is, like, basically right next to, where those bottle microwave switches are. So yeah. Let's get a connector for that. Just realized I have a bunch of, like, black connectors, but I don't have any of the, like, ones that sit on the PCB. Okay, so I think, just to be space efficient, I'll just put this one here somewhere. And can that reach comfortably? Oh yeah, there's plenty of slack there. There is no problem with that. Yeah, there is no issue with it reaching all the way here. We're good. So we can put it all the way there, and there's no problems. So let's do that. Okay, so let's go clip that far side and here. And then here's one. Just want to tack it in place. Oh wait, this is not the right tip. Oh, one modification though is that, like, to change the tips out, most of the time you use you undo a screw. But what you can also do, which is what I'm doing right now, is you can replace that normal screw with a thumb screw. And it's just an M2 thumb screw, so it's nothing too exotic of a part. Okay, let's heat that up and clean the tip. That tip is looking nasty right now. Okay, cool. So I was just tacking that on. Okay. Now the order that this goes, this side is gonna be black. Black is ground, so we will connect that to ground. Actually that's pretty convenient in this spot. Do you want to go that tight? Nah, let's not be that weird. Okay. Tack that on there. And then... oh no, that is not tacked on. There we go. Where do my flush cutters go? Here. Be back in there. Trim that. And then just kind of wiggle this in place. Oh. Ah. I messed up. Okay. I cut it way too short. I thought it was the hole next to, not the hole over it. Okay, let's try again. I have to pull out the Akko, I might have to. Okay, I didn't need to that time. There we go. That is not too long now. Or not too short now. Okay, mash that down and then clip it there this time. Put a little shorter. Okay. Got that. And then fold this over. And that's like about 7, 8-ish millimeters. Oh wow. That actually has to go slightly off. Being perfectly straight. That's okay. Because that last one is actually occupied already. And then... yeah, that is solder. And now ground is connected. Okay. So ground, and then power is going to be the second from the top. Okay. Oops. There we go, that is tacked in. I should really find a way to rest the soldering iron somewhere closer than having to reach all the way that far. Because if it looks like I'm reaching far, it is because I am reaching far. Okay. That's in, and then let's just strip that little bit. And fold that in to here. And bend that over. And we have power to the sensor. Okay. And then SDA and SDL. What did I... you know, we'll just follow this. So SCL is blue. SCL is blue. That means it's on the bottom-ish end. Second from the bottom. And blue is right at the top, so we're going to have a little bit of crossing here. But it's not going to be that much. It's not going to be a big problem. I'm not going to worry about making these ones flat. It's just nicer to have it be flatter for the, what's it called, the power ones, because, okay, just checking, blue is going to be at the end, yeah. So blue goes into the second from last. Oh wow, that is barely long enough. Okay, that is soldered, and that is soldered. Not the absolute strongest connection it could be, but it should work. Clip that, and clip that, and the other one was just the right length anyway. And then the last one is, SDA. SDA goes just above it. So SDA is going to be that one, and it is going to be Ooh, maybe I shouldn't have made it that tight. Let's still reach. It will barely reach. Nice. Okay, cool. Tack that one into there. And I think here we're just gonna do the big old blob of death. Something just fell. Okay. Oh, should probably put it here also. Okay. Yeah, that looks... That looks good to me. Sea Lion, are you done yet? You're not done yet. Okay, well, that means that we can just work on the buzzer now. Forgot what the buzzer circuit's supposed to look like, if it's just straightforward into ground from, like, any digital pin or whatever. ESP32, C3, JAO, PWM. Are all of these PWM compatible? Oh, okay. PWM can be any of the digital out pins, so that's fine. Let's see. Okay, I'm gonna reserve D6 in case I actually want to, oh, I already chose the pin for that. D9 is gonna be the buzzer pin. And let me just look up the Arduino buzzer example. If you need a great-looking, heat-resistant PLA, AdNorth makes a HT PLA Pro Mat that has an HT of 80 degrees Celsius or 100 degrees with annealing. I've been looking into high-temp PLA. Right now, I just use ABS or PETG when I need, like, thermal resistance. Is thermal resistance the right word for it? Basically, if I need it to not droop in, like, hot temperatures. But yeah, high temp PLA and super PLA are really interesting, and I haven't really messed with those before. Okay, so these usually want 100 ohm resistor. Okay, so we'll do that. So where's a spot to put the buzzer at? I did take a buzzer out, right? Pretty sure I did. Yeah, here's a buzzer. And where do I want to put that buzzer? For the antenna, I could put it here and, like, not directly on top of the power, but have, like, just a little elevated 3D printed part. Yeah, I don't think we need to overthink this, because, like, the LEDs can just be, like, out here. I'm gonna go use the bathroom real quick, actually. I am back, and I think that the Twitch break should be over by now. So I'm just gonna get 100 resistor. Yeah, here's 100. It's empty. I'll do 150. That'll be close enough. And this thing really just so that it can yell at me for, if I forget to put a medication back in or if I haven't taken it yet. So, let's see, that was gonna be D9. D9 is the 4th from the top, I think. Yeah, no, 5th from the top. Glad I checked that. And actually just wiggle that. Up there. Yeah. So that's gonna be connected to D9. Which I don't think buzzers have a polarity, really. Let me just inspect this. There's nothing here that looks... Oh, there is a polarity. Yeah. Okay. So that positive. Let's put it... That's weird, this doesn't actually fit any of the, like, normal distances. That's annoying. It kind of fits this one. It's not perfectly flat, but maybe it's just a little bent. Yeah. Okay, it's still not perfect, but it's better than it was before. Okay, so... yeah. Let's just pin that in place. And then... curl that resistor lead around that. Solder that down. Okay. And can also just trim that a little bit. Something just fell. What did I drop? I dropped a screw. Okay. And then this goes ground. Although I want to keep that lane open, so I'll actually just have it here. Yeah, that'll work. Okay. Let me just tack that down, and then we can bend it and stuff. That is connected, and then this goes all the way down to ground. Maybe I should have soldered together the pill bottle thing at the end, because I keep getting worried I'm going to pull it out. I'll probably have to inspect the connections to make sure that I didn't do that. And, you know, it might actually be a good idea for me to, let's go in. Or is it too close to the edge? Oh, sorry, Ritsuko, that's a false positive. Ignore that. That's my AI assistant.
No sweat. That's just the system getting twitchy again. Probably reacting to the subtle movements from your grip. Since you mentioned it reads a curve, I'm logging that as feedback for task 317-318. Investigate duplicate tasks issue. As inconsistent state reporting can often look like false positives. I'll make sure any task related to cleaning up finished stale items is also marked as urgent.
Thanks. That was not quite the correct task, but I'm also trying out a lower weight model on her, and I guess it's not quite ready for this. Thanks. End conversation.
You're very welcome. Good luck with the stream prep, and have a great evening.
Is it already evening time? Wow, it's 5 p.m. If you want heat resistance, their HTPC has an HET of 186 degrees Celsius. Wow. I didn't know that HT polycarbonate was a thing. But what nozzle temp does that require to print? That sounds like it needs high temp to print. Oh, I forgot to trim that. Oh my god, C-Line finally finished. C-Line is the IDE that I use for C++ stuff, including like Arduino projects and similar stuff. Let's see. I don't want to wire up the, do I want to wire up the LEDs right now? Might as well. Just gonna kind of lazy wire them up since they're just for debug right now. Yeah, sure. And then I'll figure out if I actually want to keep them for the final. Yeah, this is just gonna be kind of temporary, which is why I'm just putting it directly into there. It's not a very aesthetic position for it, but it'll work. That's kind of a shitty joint. There we go. That's in the pad. That's what I wanted. And that one's good too. And then we just need to connect the data pin. I'll just put it here, and then we'll just bridge it over. It's getting crusty. Okay. Cool, we have that. And then, where's my white? Here. Yeah, I'm just gonna estimate that much to get to D10. D10 is the one right over... I might need a bit more on that. There we go. Okay. D10 goes there, and this one goes here. That is connected. I'm gonna pin this one in. And then trim that. Bend that. And there we go. That is probably shorting, and that is fine now. Okay, cool. Yeah, I think that's actually the minimum of stuff that we need wired up for this to, be testable. So with that, now I'm just gonna assemble this together. And I expect if we have issues, I'm just gonna put like 2 of the screws in there because we will probably have at least one issue that we need to resolder something with. But I just want to see kind of what it's looking like put kind of nice put together. Let's go with that corner and this corner. Okay. And then that can plug into here. And then let's just do 2 of these ones, especially because I think I lost one of these screws and I don't want to find it, or its replacement. That's not even the right screwdriver, shit. There we go. And where's the second one? I'll just use some random one. That's too long. Where's a shorter random one? Oh, that's actually the right length. Okay. This one's gonna be less hard to put in than that first one. Okay, there you go. So you have that. And, yeah, I might as well put those other 2 in there. Actually, no, let's not do that right now. Let's assemble the other sides. T10. Oh wow, I'm surprised that could actually... so the HTPC, the high temp polycarb, 265 to 290 nozzle temp. That is surprising. I thought it'd be at least 300. But that's good to know. Okay, just because we're testing stuff out, I'm not going to put all the screws in. I'm just going to put, like, just the outer ones. Oh, wait. Yeah. Let's have it at just the weakest. The weakest clutch setting, that is. And then here. Put those 4 in. Okay. So cool. We have this thing now, and we have 5 debug LEDs. We're probably not going to keep all of these, and I don't know if I even want them in the final version. Maybe. I like it RGB LEDs. We have a buzzer. We have our microcontroller here, which is currently the ESP32C3. We have the encoder here, and that's actually kind of loose. I should probably tighten that up before we test stuff. And then we have 3 micro switches. So yeah. And then we will see if my C-Line installation and platform IO are cooperating. Because if they are, I'll just do a simple hello world just to make sure that all those are working. And then, if they are, then I'll just keep figuring out how I want to code this thing later on, off stream. And show on Tuesday what the results are. But yeah, let's hope that this works. If you're looking to buy some, use code BambooLab3D for a 20% discount. I will keep that in mind. That sounds very useful. Oh, that was plugged in my Stream Deck. Okay. Let's plug that back in. And let's get a USB-C cable for programming that microcontroller / making sure it works. Could have sworn I had a long one around here somewhere recently. Oh, is this it? Here it is. Okay. Let's move you over to one of these ports works and the other doesn't, so just kind of play with that. I think my tracking... No, my tracking did not die. Okay, that's good. Alright. Well, that turns on and I hear the Duke, so I don't think that that microcontroller is dead. Is this the Have-Z screen? This is the Have-Z screen. Cool. Okay, so let's actually move this over to here. Yeah. And then let's check out C-Line. Let me actually just hide this real quick, because sometimes the IDE is not the best about privacy. So let's go to this view for now. Okay. What's new in C-Line? Blah 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 blah. Let's make a new project. Okay. I need to configure some stuff real quick, and I don't want to show it because it's gonna show my name, I think. So, yeah. I'll just yap about what's going on. Restart the IDE. C-Lion. Alright. Need to log in to an account real quick. Assistant. Codex. How do I hide this? Guess whatever. Okay. Codex is initializing. Yeah, I've been figuring out what my AI stack is looking like right now, because I just want to end my ChatGPT subscription, because OpenAI has some issues that I don't want to keep paying for anymore. And so I've been spending the past few days configuring OpenWebUI on the Mac Mini on my ceiling that also houses my AI assistant, where if I say her name, then she will be triggered. So, yeah, I just configured it. So it has memories, it has web search, it can read images, and it's doing a pretty good job. I also configured it so that I can access it from out of home using a VPN, and I can use it on my phone, tablet, and PC. So now that means I can actually uninstall the ChatGPT apps on everything and add an extension in Firefox so that anytime I go try to type in ChatGPT, it goes to my local stack instead, so it kind of kills that muscle memory. Yeah. So that's a thing, and it's working out pretty well. Wait, I was logging in to this. Where's the login for it? Codex. AI assistant. Manage subscription? No, it's not there. There was... Oh, here it is. Sign in with account. And then after I log in here, it should be ready for me to share the screen again. I'm gonna try out Claude Code, though. Okay, what was my login for here? Oh no, it's my Google account. Oh, apparently I am signed in. Okay. New chat. That's weird, there's like beta and normal. Okay, hi, is this working? Huh. You should probably test out the resistance of the electric filament, because at least when I last checked it out, it has too much resistance to really use for like drive motors and stuff. What I would use if you're trying to like minimize and streamline everything is learn PCB design, and just kind of put everything on a unified PCB that has traces that replace the power. You may still need to put like some bare copper, just solder it along the traces to like really beef up the to beef up the conductivity. But yeah, I'd frankly be surprised if conductive filament was actually able to handle that. But who knows, it could work. There's lots of shit in robot combat where people say, you shouldn't do it, it's not going to work. And then like, it actually does work, but no one tried it out because everyone was scared of it. I've had my own experiments like that, so yeah, I'd try it out, and report the results. That'd be really cool if it actually does work. But that is just my prediction for it. Okay, it looks like Platform IO still works. Let's configure this project. Okay, so this is a seed. my god, there's like 3 entries for this. Seed, Zhao, ESP32, C3. So let's make that, and let's call this one, Cradle of Pilth. New window. Okay, that's interesting. Why does it always want to put it there when I want that there? And let's simply see if this uploads. I have to wait for this first. I'm gonna go open up an older project just so that I can import the right libraries that I want to import, which I think is really just the NeoPixel library. New window. Okay, so let's see if this even compiles and uploads. Just a totally blank project. And then let me also get the ini file for this so I can get those libraries in. Okay, looking for upload port. Upload depths. I don't think that's the right upload port, but let's keep going anyway. We're gonna be using this. And that's what I was afraid of. It's not working. Let's see. Let's try the other port. No, the other port. Oh, maybe that will work. Let's try that. What else? Nope, that one's not working. What is plugged into here? Oh, you know what? Okay, so the webcam's gonna go down for a bit, because I don't think it likes me programming anything through a USB hub. Okay, let's reconnect that GoPro. Is that doing anything? It is not. It's not saying computer connected. Let's move that port then to here. Okay. GoPro, are you working now? USB is connected. I should really, like, put some tape over or whatever on that one port that's not working. Okay, anyway, let's plug this in. Alright, let's try uploading here. Have these mode again. Looking for upload port. Nope, it's not finding it. I forgot if there was something that I needed to do with, ESP32, like hold down some button for reprogramming. ESP32 3, Zhao button reprogram, port not found. Okay. Force it by holding the boot button while connecting USB. I don't think I did that properly, because this button's like really tiny. Okay, let's try that. It's not COM4. Let's try flipping that upside down and replugging that in. There we go. That worked. So we can definitely write... Oh, wait, what? What the? That's weird. I've never had that happen before. I wonder if the connection might be fragile. Shit. It's mad. Yeah, we use Bloodsport to drive, or not Bloodsport, we use Gears to drive Bloodsport's weapon, as well as the 30-pound version. You just have to, like, do clutches and stuff and use the right, modulus and stuff, I guess. Okay, so we're finding the right port, but it's still not... Okay, I'm just gonna close out Bamboo Studio in case it's interfering for some reason. Fusion could also be interfering, because I know that it would do that when it's like trying to find 3D printers to connect to. So let's just close that out. And anything else that could possibly be trying to hog a serial port. Okay, let's try again. This is worrying. I think that what may have happened is that, like, when this thing was, like, resting on my leg and it was bouncing, and we were writing to it, it may have, like, partially written the program, but not fully. It's not seeing it now. Could also be the cable. Okay, we're seeing port 15, which is what it should be. We can write to it. I think that's what was probably going on, is that Fusion or Bamboo Studio was hogging the port. Which can be really annoying if you're doing projects that require 3D printing and CAD work. But we figure that out at least. Okay, so... let's see. Let's just define... oh gosh. I'm feeling rusty right now on my... Okay, so let's do define... what do you want to call it? Switch, pin, bottle 0. Let's have that be... Where's my pinout thing? Actually, I did it on the iPad. iPad's out of battery. I'm pretty sure it was like D0, D1, and D2. Pixel pin. That should be okay. iPad is back up. Let's go to concepts again. Check out my pinout. If this thing wants to load anyway. I want to say that's D10 though. And that buzzer pin was D9. Yes. And then define GA is D4 and SCL is D5. Fine, SCL, pin D5. Okay, cool. So, let's see. Let's do, oh, we should probably, well, okay. NeoPixel example. Okay, so NeoPixel pin. Define NeoPixel count. It's gonna be 5. Okay, and it's Adafruit NeoPixel. I think that we have to re-import or reload the project, and then do like a platform IO clean. It's not seeing that. Oh, I forgot to include the header file. Okay. So pixels.begin, pixel will show. And then let's just for and we're just gonna set the pixels color to, let's just set the model like red. And that should work for a get a hello world here. And wow, this is way better than Copilot. Okay, are we in Hamsies mode so you can actually see that? Oh, we are, but you're not able to see this. There we go. Oh wait, why are we doing pixel show there? It's not showing anything, but it is possible that this strip is, has disconnections in here. Where's my multimeter? Gonna unplug this. Okay. So this should. That's working. Is ground working? Ground is working. So what about? I don't know where you go exactly, if it's one of these ones. You have continuity and all of that, so that's not the issue. Pixel count is 5. Pixel pin, that should be 10, right? Is... yeah, that is 10. So why is this not lighting up? Oh wait, I forgot. Is that actually supposed to be float, or no, it's int, so it is 0 to whatever. let's try serial.begin. And then let's just have int test count 0, test count plus plus. We'll just see if it's actually doing something. Okay, it's looking for... It's trying to monitor at a way slower speed than we actually need it, or should have it at, so let's fix that monitor speed. That's weird, it's not doing anything. Let's swap it out for one of the S3s. That is really tight. There we go. I think it was an S3 that I had around here that, I had like a box of them too. Okay, let's just go with you. And you do come with a pair of headers, cool. Then again, if that was a dead ESP32C3, then it shouldn't have probably programmed at all. Okay, we'll just solder this down. And flex pen that. There's a solder. Okay, got all of those ones. Not sure if you can see this, if the camera's pointed at it at all. I don't think it is, but I was just putting on a brand new ESP32S3. Can y'all see this? Oh. Are there any other combat robot related soldering tools that you'd recommend? Hot air station is nice for just being like a general purpose like heat gun and like heat shrink wrap thing. I I mean, between the Omni Fixo and the, in a Pinesoul style thing, I guess a really good pair of wire strippers that you can depend on, is always great. And if you're into crimping, a good crimper... Oh! Desoldering gun is amazing, but, like, maybe not as much for robot combat, just because there's not so many connections to redo. But, like, a high-quality soldering gun, like the one I just showed, makes reworking electronics so much easier, but it's also not the cheapest thing. Okay, so this is gonna be S3 now. Let's see what happens here. What? I have to edit this config, I guess. Can we... How do we reload the project? Okay, that should work. And I'm just gonna, like... transform, reset transform. Because this is at just a wacky angle. And that's like upside down also. Okay, that's actually working, so I wasn't going crazy. Okay, transform 180. And yeah, this counter thing is going up, so that means it should be working. Although I don't see the NeoPixels actually doing... Oh, okay, so I think it's actually the thing I was talking about where you probably had some kind of continuity issue for why it wasn't lighting up. But now it's lighting up. And let's turn this off so that you can see the lights. There we go. And one of these is like a reset button. Which one is it? Reset button is this tiny thing close to me. It's not duping again. Yeah, I think this is just... I think this has, like, a faulty connection. Just wanna, like, see if there's just something I can do to, like, just kind of finagle in place while I test things out, because it's just a test bit. Yeah, I'll just do that. So, I don't know, let's just... Millis 1000. Let's see, let's have this be int time progress is equal to that. And then time progress divided by not 255. Actually, let's just keep it simple and just have this be like 255. Time progress, and time progress. And then I think this would end up making like a rainbowy pattern. Oh, okay. Plus whatever 256 divided by 3 is, something like 75-ish. My mental math is not mathing today. 150. Okay, so it's gonna be a little bit off. Let's actually go with plus 80, 160, 240. Let's go with 84. 84, that's 168. And then let's have it be plus 255 divided by 5 is gonna be like 50, yeah. Ish. 50 times I. Modulus 255. And I think that'll end up making a cool rainbow thing, I'm not sure. Oh, I know what's going on. This is already being used. Yeah, it's kind of rough, but it'll work. Let's actually delay it by 10 so it's smoother. It's really bright. Okay, well, this isn't even important. This is just me messing around. Okay, so let's not actually do this. This is really silly. Okay, so let's actually set up the buttons. Let's see. Cool. Bottle. In place. And then here, pin mode, input pull up. Is pull up the one that I wanted? If I consult this, yeah, pull up, because completing it should bring it down to ground. Okay, so here, let's do, place is equal to that, and then let's just see if, let's see if that works, or if we need to invert the logic. Okay, so and this one, that works. I just need to invert the logic on that. And then we can also have it so that pixels is okay. What was the syntax for that again? Pixels dot set pin, no, set pixel color, I think. Okay, yeah. 0 in place. Else. We'll make it green. And let's also define neopixel count, or not neopixel, bottle 0 is gonna be, yeah. Thank you, autocomplete. What was that? So if it is in place, then we want that to be 255, or we want that to be green. And if it's not, then we want it to be red. And we'll just do it for the other ones. Thank you, autocomplete. This is great. And I think I will reverse the order of those pins. Okay, so let's see. That should be pretty easy. Okay, so I think that let's turn this back on. Yes, if we just press it. Yeah, that works. That works, and that works. So we'll know if all the medications are in their home. And then the next thing, let's do, let's work on the buzzer. If Arduino buzzer example. Okay, so we're gonna set up the buzzer. Tone buzzer pin. Else. No tone. Easy. So this is definitely not going to be the final program at all, because we don't want this buzzing all day. That'll be annoying as hell and defeat the purpose of this, but it'll help us test at least. Because I just want to hello world every single input and output, just so that, oh. That's, weird. Okay, what does that mean? SP32S3, tone, no tone. It does not have tone and no tone. That's why the LED thing is going nuts. So to do it, we actually need to define buzzer channel 0. And I think I'm actually just gonna start to split those up by functionality. So, yeah. This would be LED C setup. attach that pin. And then instead of tone, no tone, this would be, let's set this to 1000 hertz. Yeah, there's a lot of functions in the Arduino standard library that do not work on things like ESP32C3 and such. Okay, that's not giving errors. We should hear buzzing now. I don't hear shit. Let's just... buzzing... not buzzing. Actually, let's have it on the same line. Not buzzing. Buzzing. Okay, I'm just gonna ask, can you sanity check why buzzing is not working in this script? And let's do read-only mode. In the meantime, let's see how if we can get the encoder doing its thing, because that's actually kind of the most important bit that I still have not tried out yet. So this is the AS5600 encoder, and let me go look for a library. Okay, let's try this library out. Okay, interesting. $1,000 is out of the range, apparently, of that. Okay, let's try that again, because I think that the AI agent thing was interfering. Well, that worked, so it was interfering. Let's see. So apparently, if we set this to 255 instead of 1,000, that will work. It's not working, but that's okay. I'll figure that out later. I just really want to know if that encoder works. So let's do let's find some example code for this. Examples. Okay, so include AS 5600.h. It's not seeing that, so let's reload it. I wonder if... Oh my gosh, I could have just been pressing that the whole time. Okay, I can see that. So this is gonna be the config for the, wow, my feet are going nuts. My tracking is going nuts, but anyway, okay, so, AS 5600... We'll just call this one encoder. Wire.begin. And then let's do encoder.begin wire. What is that for supposed to be? Direction. What if I don't want the direction pin? Because it says it's supposed to be optional. Bool encoder connected. Let's add a little delay to this. And then... let's see if that works. Oh, it's because we're still running it on there. Encoder is connected. That is great. So let's have it read the encoder angle. It's not get angle, it's read angle. I don't know if it's gonna be degrees or radians. Okay, so it says it's 700 degrees, so let's spin it around. Oh my gosh, it works! Woohoo! Wow. So yeah, I'm spinning the roller around, and it is doing stuff. And it looks like that the minimum is 0, and the maximum is 4,800 something. Might be 4,690. Yeah. So, is this even in degrees? Or what? That's not degrees. So I don't know what that is, but I do know that we don't really actually need to know what the angle is. We just need to know what it is relative. So let's see. Int current. Let's see. Let's have it so that int current angle is equal to 0. And then here we're gonna do some funny stuff. Int current angle is equal to encoder.read angle, and then int new angle is that, and then if new angle is not equal to that, if new angle, and let's make a tolerance thing. Int angle change tolerance. Toledo? Why was it Toledo? Ohio is leaking. What's the math? ABS. Does this library exist in here? Oh, we just have straight up an ABS here. So this will almost work, except on the case of wrapping around. No, that's not the right branching. And let's actually move this to the end, because it's not going to be, like, clean, I guess, in terms of, thingy. And let's just have print serial.println blank. Oh, well, no, that doesn't matter. Status. So this does not account for wrapping, but it'll account for everything else, I think. Did I get rid of... Okay, that should definitely not be there, otherwise it just completely screws over all this logic. Let's see if that works. That was probably the easiest sensor to get working I've ever messed with. I'll take it. Okay. Oh, huh. Oh no, that should be over, not under. Ooh, hydrate was redeemed. There it is. Thank you. Yummy water. Okay, so where does this say encoder? I'm just gonna add the space here. Alright, it's 1 in the morning. I got to get some sleep. Looking forward to an update on the driving tool whenever we get around to it. Yeah, I do want to make a video about it, so, yeah, if you subscribe, you'll eventually see it, hopefully. Thanks for tuning in, and for joining me this stream. Hope you had a fun time, and get some good sleep. Okay, so if we turn this... Turn right, turning left, turning right, turning left. That is perfect. That's what I wanted. And so, the only time it's not going to work is when we wrap around from there to there. Okay, so... Yeah. Let's see, int overflow, positive is equal to, okay, let's set some stuff here. Int maximum angle is equal to that, I think. Let's set the tolerance up to like 10. And let's actually set current angle to, if that does change. So overflow positive is equal to, maximum angle minus that, int overflow negative possible. Cool. False. Cool. Flow negative is equal to false. And let's actually just... Why is that -1? That does not make sense. We'll just worry about overflow positive first. Okay, so if current... That should not be current angle, that should be angle change tolerance. Current angle, is... Let's call that possible window. You know, I think we actually do need both of those. Overflow end and overflow start. If current angle is overflow end possible window, and new angle is smaller than that, then overflowed positive is equal to true. If current angle is smaller than that window, and if the new angle is over that, then overflowed negative is true, which was not defined. So if either of these, positive, or all of that stuff, flowed negative, did I misspell that? I did. Okay. And then... define neopixel encoder 3. And else... we'll have it so that, pixels set color, pixel encoder, will be off. Well, actually, let's just make it, like, kind of hum, like, some kind of color really low. if it's turning, but not that much. Just not turning at all. No, actually, the whole point of the, of that is that it doesn't show when it's, like, just kind of ambiently changing like it is right now. So if we're turning left versus if we're turning right, let's just have it. Okay, so we're already using green and red. So let's use blue and yellow, I guess. 255. I believe combination of green and red is yellow. And let's see how that goes. Yeah, these streams will be like a mixture of coding and CADing and building and stuff. Okay, if we spin this... Okay, it looks like... Okay, so this is working exactly as it should. So if we're dispensing medicine, then that should glow yellow. Okay, so I think the last thing I want to do before ending this stream for now is just demonstrate it with the actual pill bottle things. I'll probably have to like rig this up so that something here. There's like some kind of broken trace here going on, but I'll just try to hold that down and see if that works. But yeah, let's get a roll of meds loaded in. Okay, so this box of meds is in. Let's take the tail end. Okay, so that's loaded, and then I'm gonna just hold this down. But yeah, as this spins, this is really unreliable. Okay, so as this spins, when we're pulling the meds out, this is yellow. So if it says, oh, it's been yellow for some amount of spinny spins, then you can say that I took my meds for the day. And we're not going to have a reverse case, that's just for testing purposes. And then let's force that there again. Let me find my other pill bottles. So right now, there are no meds in here. Green, green, and more green. So we can sense if the meds are in there. And that's great. Yeah. Okay. Let's see. I'll figure out the buzzer later. It's not super important, but you got the other stuff in, and I think that I actually want to do something kind of cool with the LEDs. I'm thinking that we actually have an LED right behind each bottle, so that like you can actually kind of backlight the bottle. That'd be kind of cool. And then could have an LED just kind of on the front here, or maybe it can't be up here because it'll actually be blocking the view of it. We could have it over here. No, that's gonna be kind of weird. I think we could just have it maybe here somewhere. I'll figure out where to put it, but there should be an LED for, oh, you know, could actually put it here-ish. Yeah, I'll think about that. It'll require redesigning this a bit, but that's not a big problem. Because we can just borrow power from here, and then just add in one more connector in there. I'll figure it out. It's not a big problem. Yeah, so we'll have those debug LEDs in there at least. then the buzzers are supposed to buzz if I haven't taken my meds or if I haven't placed my meds in there yet. But yeah. And then this will have some kind of API that my AI assistant can ping every once in a while to check what the status of my medication taking is. And it should also be able to work standalone. But yeah, that is where we're at with the Cradle of Pilth. We have made quite a bit of progress. We also just need to make a little enclosure for this too, so that's not like all exposed and stuff. And then this thing was basically done and ready to go, and I actually want to get it functioning like today or tomorrow, just ASAP, because I really do need something to help me keep my take my meds all the time. So yeah, I'm just gonna work on that, I think, and then Tuesday will probably be like the final thing, the final stream of this when it all works, and kind of probably more of just a demonstration stream, I guess, because I don't know what my next project is right now. But yeah. Oop. Well, at least the cable didn't rip out this time, because the last time that happened, a USB port broke off. But nothing cracked on here, I don't think. I think it's all safe. And I didn't hear a doo-doop until I intentionally unplugged it, so yeah. I mean, I can just make sure that all the wiring survived that. Although that may have... Okay, everything survived, I think. Yeah, so we're good. Okay, well... Alright, I am going to end the stream here. Let's figure out who to raid. I pressed the wrong button. Okay, let's figure out who to raid. Let's see. Ty is, on right now, so if you are tuned in on Twitch, then we will raid Ty. Yay! Okay, so as soon as we're done, as soon as I press this raid button, I'm gonna go end the stream.